Hi, this is Javier Encinas. Thank you for downloading your free 15-day trial of ASDIP. I'm confident that you will enjoy the evaluation experience. Today I'm going to show you how user-friendly the software is and how easy it is to produce, check, and optimize your calculations. In this case, I will design a cantilever retaining wall using ASDIP Retain. I will show the other products in other videos. The typical calculation window is composed of the menu bar at the very top, where you can access many useful commands. Immediately below the toolbar, same. And here is the working area, which consists of two tabbed panes. The left pane is designed to enter the input data, and the right pane is designed to show the results of your calculations. In this video, I will focus mostly on the calculations and reporting features and capabilities of the software. The input tabs are organized in a logical way to avoid confusion where to specify a parameter. Geometry, where you define all the dimensions of the wall. Loads, all the loads acting on the wall and the backfill. Surcharge, concentrated loads, if any. Here is wind and seismic loads. In the material tabs, you specify all the material properties for the stem and for the footing. In the reinforcement, all these commands and controls let you specify all the rebars and customize the reinforcement of the wall. So it's very user-friendly to model your structure. Okay, in the results tab, you can see different ways to show the results. The results are presented in three different ways. At a glance, shows the results like a summary with the most relevant information that fits in one screen. No scroll bars. You can see at a glance if the design passes or fails. For example, in this case, I can see at a glance that there's a problem with the sliding. It's failing here, so I need to check what happened with the sliding calculations. Bearing pressures are okay. Shear forces for the members all are okay, no problem. In the reinforcement of the members, the stem is okay, everything passes. The toe, yeah, it's passing, but the heel is failing in the moment capacity, and so we need to check what happened with the rebars or with the size of the heel, and also there's a problem with the minimum area of steel. So this is a very useful way to check if the design passes or fails. If you need more detail of the calculation, you go to the next tab. The condensed calculations shows a more detailed set of calculations. It's intended for a more in-depth checking of the results. The calculations are organized by topic, as you can see here, for easier reading, and consists of values and text messages with individual checks. Also, you can see that the controlling combinations are reported in this view. So it's a more in-depth way to present the calculations. For example, here the overturning calculations of the retaining wall are presented very nicely. You can see the overturning factors or all the forces and the lever arms and the moments that are produced to overturn the wall, and here is the resisting forces of the wall, and so on. In stem design, you can see all these calculations step by step. Sliding, here you see the combinations in the wall. Heel design, toe design, etc. So it's a very useful way to check the calculations as well. If you need even more detailed set of calculations, go to the next tab. The detail shows a very detailed report of the results with step-by-step calculations for granular checking. The results are organized by topic as well for easy reading and include exposed formulas like this, like that, exposed formulas, and a reference to the design code. like this one, for example. So you can see every single calculations in your design is reported here. Nothing is hidden. You can check step by step. No intermediate calculations omitted. Everything is reported here. So you can check step by step all the calculations. Everything. Your plan checker can also come and check all these numbers, and it's very appropriate to have this kind of checking for inspections and granular checking somebody else. The stem design with the load combination that controls. So it's a very nice way to see the calculations in that way. Expose formulas and reference to the code. Graphically, the program also shows the results. For example, in this tab, the stability tab, you can see the soil bearing pressures of the wall with the values. Here is the passive pressure that resists sliding. And you can see the pressures applied in the backfill side. The surcharge, the backfill itself, the water pressure, the water table. Here is the seismic load and wind, if any. So you can see everything that is applied to the wall. In the lower view, you see the forces produced by all these load cases are shown here very appropriately. You can see at a glance what happened, what's going on, what the results are of every aspect. For example, the passive, you can see exactly what the passive is, or the resultant, or the friction, or the resultant horizontally, or the resultant vertically, and everything is labeled. So it's a very nice way to see the forces applied to the wall. And you can see all these by load combination, so if you check the envelope, you see what is controlling, or you can select any other combination and you can see, the results. The safety factors are shown here for reference, so it's also a very nice way to check at the same time graphically the results and how far are you from the limit. In this case, for example, the overturning is much more than the minimum, and the sliding as well. So you have probably some allowance to reduce the member somehow, or that depends on the calculate or the combinations. For example, in this combination, which is the envelope, the sliding fail and the bearing pressure fail as well. So no, the bearing pressure is okay. It's the sliding that fail. Okay, regarding the stem, this graph shows the concrete design of the stem. Here you can see all the pressures applied to the stem, similar to the stability, but in this case it's another load combination, and it's applied just to the stem without including the footing, the surcharge, the backfill, the water table, and seismic and wind. Also, is per load combination. You can select the load combination here. In the lower view, you can see the moment diagram generated by the program, and the shear diagram as well. It's also it's important to note that whenever you change anything in the input, you see immediately the change, the effect in the calculations. So whatever you change here, for example, let's put a cutoff. Check this moment diagram here. I'm going to cut off the reverse. You see, when you cut off the reverse, the bending diagram changes. So everything, the effect is immediately reflected in the calculation when you change something in the input. In the construction tab, you can see the details showing the reverse, typically the cross section and the elevation view, similar to what you would produce in a drawing. The reports You can produce two types of report: condensed report or detailed report. Let's see the condensed report. This is a print preview. Okay, well, you can see here, similar to what we saw in the condensed tab, you can see it in the condensed report with the graphic information already placed there, pre-formatted, so you can easily print out all this, and everything is nicely formatted and done. The same applies to the detailed report. Let's see the detailed report. This is a print preview of the detailed report. Similar thing. You can see all the calculations with exposed formulas and the code references, similar to what we saw before with the information of the graph. So it's neatly presented, and you can print out and present to your client, to your plan checker. Okay, well, thank you for your attention to this video. Enjoy the evaluation period. If you have any questions, any doubt, comment, suggestion, please let me know. I'll be glad to help. Thank you very much for your attention, and see you in the next video.